up until this point, we've relied on the textbook to give us the chemical formula for compounds. And we've been able to do multiple calculations based on the formula. Now, we are going to learn how to actually create the chemical formula for these compounds based on the information, based on the quantitative data that we're being provided. Now, there are two different types of formulas that you're going to learn how to write. The first one that you are going to learn about in this video is called an empirical formula. Now, an empirical formula is the formula that represents the lowest whole number ratio of atoms in a compound. And I'm going to explain what exactly that means in 1 second, but I'm going to write this out right now. So it's the formula that represents the lowest whole number ratio of atoms in a compound. So let's look at a bunch of examples to really understand this definition that I just gave you. So, for example, if I give you C6H12O6, this molecule is glucose. Now, if you notice, this isn't the simplest whole number ratio. So therefore, this is not actually the empirical formula. There's a 6, there's a 12, there's a 6. You can reduce this. It's not the lowest whole number ratio. So if I divide all of these coefficients by 6, sorry, these subscripts by 6, I get CH2O. Now, the purpose of the empirical formula, which this orange formula is, the purpose of it is to tell you the ratio of atoms within a molecule. So for example, I know that for every 1 carbon atom, there will be 2 hydrogen atoms and 1 oxygen atom. This formula here, which we call the molecular formula, does not tell me that, only the empirical formula. Another example would be CH. For every 1 carbon, I have 1 hydrogen. So if you see a formula in which you have the simplest whole number ratio, the lowest whole number ratio, you know you have the empirical formula. So there are actually a couple of examples in which we use the empirical formula when we're talking about compounds. For example, CO2. CO2, carbon dioxide, this is the lowest whole number ratio. You can't reduce it further. There's 1 carbon for every 2 oxygens. So sometimes the empirical formula is the same as the molecular formula. So this has the same empirical and molecular formula. Not always though. So what I've showed you right here is the steps that are required in order to write the empirical formula of a compound. So if you notice in this example problem, I start off giving you the mass of each compound. So I don't start with this first step. This just gives you, if I were given percent, I would start there. I'm actually starting right here with grams. All right, and so I'm going to go through these steps in order to find the empirical formula of this compound. So I start off, and I've got a compound that has a mass of 2.50 grams. All right, it has 0.900 grams of calcium, so I'm going to write this 900 grams of calcium, and it has 1.60 grams of chlorine. Now, the 2.50, guys, was just extra information that you didn't actually need, so ignore it. Now, I'm in grams. My next step is to convert to moles, and so that's exactly what I'm going to do. So, in order to convert to moles, I need to use the molar mass of each of these atoms. So, I'm going to start with calcium. I'm going to put grams of calcium on bottom, moles of calcium up top. If you see a gram to mole relationship, that should tell you that you need to use your molar mass. So the average atomic mass of calcium is 40.80. Sorry, 40.08 for every 1 mole. I'll do that in a second. I'm going to do the same thing for chlorine. Grams on bottom, moles up top. The average atomic mass of chlorine is 35.45 for every 1 mole. And now I just need to calculate this. So pull out your calculator. If I take 0.9 grams of calcium divided by 40.08 grams, I get 0.022. 0.022. Let's say 5, I'm going to round, moles. Okay. Here I take 1.6 divided by 35.45, and I get 0.0451. Now my next step, so I've done going from grams to moles. My next step, divide by the smallest number of moles. Now I've got 0.02 here, 0.04 here, which tells me that my smallest number of moles is the 0.02. So I'm going to divide both of these by my smallest number of moles. So I'm done with the third step. Now I'm going to use the whole number of moles as the subscript. So as you will see, if I actually divide, I'm going to write calcium here, I'm going to write chlorine here. If I take 0.0225 divided by 0.0225, I get a 1. So there's an implied 1 here, which I'm not going to write. And then if I take 0.0451 divided by 0.0225, I get 2.00444444. If you have 2.0, you can assume it's going to be 2. So the empirical formula for this compound is CaCl2. And I'm done. All right. Now, if instead of giving you mass like I did in this example problem, I were to give you percent, you first need to convert from percent to grams. Now this is easier than it sounds. If we assume that we have a compound with a mass of 100 grams of that compound, and 79.8% of that is carbon, then I can assume that the mass of carbon is just 79.8 grams. Okay. For hydrogen, it's 20.2 grams of hydrogen. And then I've already done this step. That's good. Now you can keep going. All right? So I want you to complete number 1 for homework, please.